So today we're classifying triangles. We're going to classify by their angles and by their sides, and then we're also going to calculate and find missing angles inside the triangles. Pretty much what I just said. So we're also going to classify them according to the length of their side and the measurement of their angles. Most of this will be review as we get started. All right. We have straight angles, obtuse angles, which are greater than 90 but less than 180, acute, less than 90, and exactly right angles, which are 90 degrees. So if you want to define those, you may want to write that down in your notes to define those. And then we'll go more specifically into each one, so I'll give you time. Okay. Right triangles have exactly one right angle. A right angle is equal to 90 degrees. It will be indicated, even if not given the message or the number 90 degrees. Sorry about that, that's a little distracting. It will have the box instead of an arc in the angle measure, so you know that it is equal to 90 degrees. Acute triangles have all three acute angles. So that's important to understand that all three measures of the angles inside an acute triangle are going to be less than 90. Okay? So acute angles, that's shown by the light blue line there, are less than 90 degrees. And sometimes it's really hard to tell from looking. And in fact, we're going to have an example later that you have to go by the mathematical measurements and the concept of knowing the total number of degrees in a triangle, more so than just looking at the angle in the triangle. So all of them are smaller than 90. Okay. When we're talking obtuse, we're talking about one obtuse angle. Obtuse is greater than 90. Okay, now let's talk about their sides. If you have a triangle with three equal sides, we will call that an equilateral triangle. And usually these tick marks, or these little marks on the side of the triangle, will let you know which sides are equal to each other. So if there's one on each, then all three are equal. Isosceles triangles have two equal sides. And we call a triangle with no equal sides scalene. So no sides are congruent to any other. So the tick marks are obviously different, 1, 2, and 3. That indicates three different measures of side lengths. So this one slide, this next slide, would probably have been all that was sufficient, because it summarizes everything that we talked about. Now we're going to classify according to the angles. We have equiangular, all three are the same. Acute, all angles acute. Right, one right angle, and obtuse. Another slide that just kind of summarizes all of it. So if you're still, kind of getting stuck on how to classify, I think this would be the one that would be most beneficial to pull up. All right, so let's look at now finding and classifying classifying triangles by angles and by sides. So if we look at number 1, we see three angles. All of them are less than 90 degrees, and none of the sides appear to be the same. For number 2, we have 1 obtuse. And here's the clue here that it's isosceles is because the angles opposite of equal sides are equal to each other. So since we have 20 and 20, that indicates that, let me get a color here that'll show up. That indicates that this side is equal to this side. So that's one clue, is because those two opposite angles are 20 degrees. All right. So you've learned about triangles being classified by sides or angles. Now let's talk about all the different angles in the triangle. So we have the theorem. So the sum of all the measures of the angles are 180. The acute angles of a right triangle are complementary to each other. Since one angle in a right triangle is 90, the other two must add up to 90, meaning they're complementary. The measure of each angle in an equiangular triangle is 60. So what's true about equiangular triangles is that they're also called equilateral triangles. All the sides are equal, and the angles opposite equal sides are all equal to each other, so that makes sense. So the measures of all the angles equal 180, or a straight line. So we're going to use all of this information then to help us find a missing angle inside a triangle. So if we have a triangle, two of the angles are 60. This is the first example on your notes page. What must A equal? So one way to find out, if you want to show your work, would be to take A plus 60 plus 60 equals 180. So if we combine these two, we get 120. So if we subtract 120 from both sides, right, we'll get A is equal to 60 degrees. Okay, it's real hard to see even on the slide, but there is a right triangle. So we know that that symbol for right triangle right here tells us that this angle is 90 degrees. So 90 plus 22 plus B equals 180. So if we take these two and add them together and subtract that from both sides, we'll get B is equal to 68 degrees. All right, let's try this one. In this example, it's already done for you. Yes, let's click through the slides then so we can discuss it as we go. So we're going to find the measure of each interior angle of this triangle ABC, where measure of angle A is x, measure of angle B is 2x, and measure of angle C is 3x. Then we're going to classify the triangle by, it doesn't really say by what, but by its sides, by its angles, we can decide later. Okay. So A plus B plus C must equal 180. So x plus 2x plus 3x equals 180. Combine like terms so that we have 6x equals 180. So far so good? Adding them all together. Divide both sides by 6 to get the value of x to be 30. Now we need each angle measure. So angle A will equal 30 degrees. Angle B will be 2 times 30 degrees, or 60 degrees. Angle C would be 3 times 30 degrees, or 90 degrees. And that's what I'm talking about with that 3x does not look like a 90-degree angle, but go with the math here. The drawing doesn't always indicate what the actual angle measure is. And that's going to be similar to what I'm going to ask you to do in your homework. I'm going to give you possibly expressions for each angle. You know that you add all three up and they equal 180. And then you can solve for x and for the angle measured. If we're asked to find the angle measures and then classify the triangle, and the ratio of angle measures in a triangle is 3 to 4 to 11. All right, so we have a triangle. and we don't know what the angle measure is, we can turn this into an equation of 3x plus 4x plus 11x has to be equal to 180. So again, I wouldn't even have a clue how to draw this triangle. We'll just draw something like that. Just to give you an idea, okay? So all of them add up to 180. So when you combine the coefficients, 3 plus 4 plus 11, you get 18x equals 180. So we can solve that x equals 10. So the 3x triangle would be 3 times 10, or 30 degrees. The 4x triangle would be 40 degrees. And the last one, 110, and it's obtuse. So I kind of drew it that way. Again, check your work by adding all those numbers together to make sure that they actually do equal 180. But if you're given the ratio, it is 3 to 4 to 11. Just add that variable of x, solve for x, and then calculate the actual degrees. For classification, because none of the angle measures are the same, that means none of the side lengths are equal to each other, so it is definitely scalene, and one of the angles is greater than 90. So obtuse scalene would be a great name for this triangle. All right, find the measures of the acute angles of the right triangle in the diagram shown. Okay, so we know that this one is our 90-degree angle because of the red box. So we have an expression, 90 plus 2x plus this whole expression, x minus 6 equals 180. I'll go through and combine like terms, okay? Make sure you keep that -6 with that term so that we know that we're taking 90 plus -6 and getting 84, 2 plus 1 and getting 3, it's positive 3, equal to 180. So if we subtract 84 from both sides, we end up with 3x equal to 96, and divide by 3. X equals 32. If x equals 32, 2 times 32 is 64 degrees up here. 32 minus 6 is equal to 26 degrees here, and we already knew 90 degrees, so we could label all three. And again, check your work. 64 plus 26 plus 90 must equal 180. And to classify this one, we would call it a right scalene. Remember that if none of the angles inside are equal, then none of the side lengths are equal. And those were the two missing angles that we needed, 26 and 64. Okay, so find the unknown side lengths of the triangle given the perimeter. Then classify the triangle by its side length. So we know the perimeter of a triangle, and we know that perimeter is the distance all around the outside. So we have to add side A to side B to side C or whatever to get 91. So we have an equation based on this. Looking at the first one, 6x minus 8 plus 2x plus 1 plus 6x equals 91. And just go through and combine like terms till you can get 14x minus 7 equals 91. Add 7 to both sides. If 14x equals 98, by dividing both sides by 14, we find that x is equal to 7. Therefore, this side would be 6 times 7 minus 8, and it will be 34 inches. This side will be 6 times 7, or 42 inches. And finally, this side will be 2 times 7 plus 1, or 15 inches. And we've done a lot of work with scalene triangles today, haven't we? So it would be a scalene triangle to classify by its sides.